here. There we go. There we go. The recording should be starting. Great. We are working on Unit 3, Automobile Ownership. We've been doing this for a while. And this is a new lesson, Lesson 5, Driving Data. All right, driving data. This is day 1, which means there'll be a video and there'll be a lot of me talking at you to deliver you to the instruction you need to be able to hit these learning targets. And what are those learning targets? They are, I can write, interpret, and use the distance formula. And I can use the formula for the relationship between distance, fuel economy, and gas usage. All right, I'm going to click on the form link, and then I should see this little picture here, like a steering wheel with some data there, right? This should be the image you should see for today's lesson. There are our learning targets. And because this is a new lesson, we have some new vocabulary. All right, the first little term here is odometer. Odometer. This is the little thing on your car that measures how far the car has been driven. All right, they come in 2 different forms. There's the electronic form, which gives you a digital readout of how far the car has been driven. And then there's the mechanical one, which has little cylinders that flip. And this gives you an idea of how many miles the car has traveled, which gives you an idea of how much the car has been used. There's also a thing called a trip odometer. This gives you an ability to measure the distance of a particular trip. Usually you'll hold down your odometer button for a couple seconds, and then the trip odometer will reset to 0, and you can measure the distance between home and work, or between home and a camping spot, or whatever you want to measure distance to, between 2 points. Then there's the thing you're all familiar with. There's a thing called a speedometer. A speedometer that measures your speed, the speedometer. Right, speedometer. We're going to be talking about fuel economy measurements in miles per gallon, right? MPG, miles per gallon. That's how many miles a car can travel on 1 gallon of gasoline. We'll also be doing some looking at kilometers per liter, right? Kilometers or kilometers per liter. How many kilometers can a car travel on 1 liter of gasoline? We'll be talking about the English standard system. This is the standard unit of measurement we have here in the United States. All right. Everywhere else in the world uses this thing called the metric system, which makes a lot more sense and has a lot more predictability and standardization. We'll be looking at a distance formula. That's distance will be equal to rate times time. I'll be doing all sorts of little manipulations with that. And then we'll also be looking at currency exchange rates. We use the US dollar here in the US. Other countries, they have their own money, believe it or not. And you need to be able to sometimes convert, dollars into pesos or dollars into Canadian dollars in order to figure out what things are worth. All right, so these are the math topics. If you want to take a look at them, I'm skipping that. We're on automobile ownership. We're on driving data. Put your name in where it says your name. And we're learning targets. We will go up here and we will copy and paste our learning targets as per usual. Right, I'm selecting them. I am copying them. Right click, copy. I can come down here and right click, paste. There. Now we have a guarantee that you've at least looked at these at least once. The first question I'm going to ask you is, what would you prefer to learn next? What would you prefer to learn next? Do you want to learn about independent living? Like, we have 6 weeks left of this year, right? So we probably got time for, 1 more unit. Do you want to learn about independent living, which is like buying a home, renting an apartment, paying for utilities, figuring out square footage and what all that kind of stuff means, a little geometry? Or would you prefer personal budgeting, calculating income and expenses, making financial plans for the future, saving to buy a car, these kinds of things? So independent living or personal budgeting. I don't know if we'll have time for both. Let's see. Okay. Once you get done with that question, I have a few warm-ups. I overdid it on the warm-ups. I almost feel like I should skip some of these. Today because I'm about to, let me skip them. I'm going to skip all the warm-ups for now because I feel like I need to introduce you based on the data we have from last class. Let me introduce you some of these ideas first, and we'll come back to these. Let me just start with this little text wall here. What data is important to a driver? The dashboard of an automobile is an information center. The dashboard supplies data on how much fuel you have, what speed you're going at, what the current time is, and engine operating conditions. The dashboard can also give you information on the inside and outside temperature. Some cars even have a global positioning system, GPS, mounted to the dashboard. This can help a driver find destinations or map out alternative routes. And you may not know this, but your cellular phone can be wirelessly connected to your car, so you can send and receive hands-free calls. There are many advances in information that the driver has available to make trips safer, smarter, and more energy efficient. The odometer indicates the distance the car has traveled since it left the factory, right? So that odometer there is measuring how much the distance the car has traveled since it left the factory. All automobiles have either an electronic or mechanical odometer. Some dashboard odometers give readings in both miles and kilometers. An electronic odometer gives readings digitally, right? It'll give you the actual numbers. While a mechanical odometer consists of a set of cylinders that turn. I don't know if you guys have even seen vehicles that have mechanical odometers lately. They're not becoming less and less common. I'll include a picture of those sometime. Many cars also have a trip odometer, which can be reset at the beginning of each trip. The trip odometer gives you the accumulated distance traveled on a particular trip, while the speedometer tells you the rate at which the car is traveling. The rate or speed is reported in either miles per hour, mph or mi over h, or in kilometers per hour, km over h or kph. Drivers are concerned not only with the distance traveled and speed, but also with the amount of gasoline used. We'll be talking about some questions with that. Gasoline is sold by the gallon here in the United States or by the liter everywhere else. Over the last 20 years, the price of gasoline has changed dramatically. Economizing on fuel is a financial priority for many people. Car buyers are usually interested in the fuel economy measurements. These are calculated in miles per gallon, either mi over g or mpg, or everywhere else in kilometers per liter, km over l. In order to understand these fuel economy measurements, it is necessary to have a good sense of distances in both the English standard system, that's what we use, of measurement that's used in the United States, and the metric system used pretty much everywhere else. Okay, so this is kind of like gives you an idea of why I'm making fun of this a little bit, right? You may not know this, but a mile equals 5,280 feet. So in order to understand how many feet are in a mile, you just have to memorize that there are 5,280 feet in a single mile. Well, on the other hand, a kilometer, see how it says kilo? Kilo stands for 1,000. So a kilometer is just the same thing as 1,000 meters, right? A kilometer, it tells you how many meters are in a kilometer because it says kilo there, which stands for 1,000. If it was kilograms, there'd be 1,000 grams in 1 kilogram, and so on. So you can kind of, just by looking at the word, you know how many meters or grams or whatever goes into a metric system measurement. However, we can do some conversions here, right? We can do some conversions. For instance, 1 kilometer is equal to 0.621371 miles, right? So if we knew how many kilometers, we could multiply it by this number here, and we would get the miles. 1 mile is equal to 1.60934 kilometers. So if we knew the miles, we could multiply it by this number to get the kilometers. These are called conversion factors. All right, to give you an example here, like say, if you guys know where Seattle, Washington is, out west. If you're to travel from Seattle, Washington to Vancouver, British Columbia in Canada, it's about 176 kilometers, or you could say it's 110 miles, right? A kilometer is slightly, it's quite a bit less than a mile. Therefore, there's always going to be more kilometers than miles when you put them both side by side over the same distance. Yeah, conversions. When traveling, it's important to use the correct measurement system. Miles per gallon is a unit of measurement that gives you the number of miles that a car can be driven on just 1 gallon of gasoline. A car gets 28 mpg can travel about 28 miles on just 1 gallon of gasoline. A car that gets 11.9 kilometers per liter can travel about 11.9 kilometers on 1 liter of gasoline. And since there's about 3.8 liters in a gallon, or about 0.26 gallons in a liter, when shopping for a new car, always ask for the fuel estimate. Okay, woof, got through that. We'll start example 1 in just a second. All right, example 1. A car travels at an average rate of speed of 50 miles per hour for 6 hours. So it's going 50 miles per hour for 6 hours. How far does this car travel? How will we solve this kind of question? We're going to use the distance formula. It looks like this. Distance equals rate times time. All right, distance equals the rate times the time. D is the distance traveled. R is the rate. T is the time in hours. So distance equals rate times time in hours. All right, so if we know that we're traveling at 50 miles per hour, we can stick 50 in for R, like they've done right here. They stuck the 50 in, substituted R equals 50. They traveled for 6 hours. Therefore, we can stick in 6 for T. Right? Well, 50 times 6 is 300. Therefore, D is 300. Therefore, the car has traveled 300 miles. Kind of get a good feel for that? All right. How about your turn? Your turn. A car travels at an average of 65 miles an hour for 4 hours. How far does the car travel? You can, if you're feeling brave, you can come on microphone. If you're not feeling so brave, you can let me know via chat. How far does the car travel? I know it's Monday. I'm looking for some participation today. Wonderful. Thank you so much, sir. Williams got it. Anybody else? Right, Mr. Cranbill's trying to break it down for you, right? 4 hours, traveling 4 hours. If you're traveling 65 miles per hour, right, you could just take 65 plus 65 plus 65 plus 65. You could find out that way. The easier way might be to do 65 multiplied by 4 hours. Same thing. All right, 260 total miles. The car travels 260 miles. All right, next question. You guys are getting really good, actually, at this algebraic expression. I've been really proud to see how well you guys have been developing with algebraic expressions. All right, this one, a car is traveling at R miles per hour for M minutes. Write an algebraic expression for the distance traveled. All right, give this a shot. See what you can do with this. William, that's a really good start. The only problem is that it gives us M for minutes when T has to be time in hours. That's the only problem there.
I'll throw the links in the chat.
Sure, great. We're going to be throwing the links in the chat momentarily. I'm looking for some algebraic expression here. We'll start with your formula. D equals R times T. All right. R is miles per hour. T is hours. So let's see. We can leave the D as distance. That's fine. We can leave the R as miles per hour. But the problem is that putting M in for minutes is not quite enough, right? Because T is time in hours. So how do I convert minutes to hours? What can I do to the minutes to make sure it shows up in the equation as hours? I gotta think, how many minutes are in an hour? And how do I convert? Yeah, I gotta multiply it by 60. So if I multiply minutes by 60, this will work, because M times 60 is the same thing as, T hours. So all I'm really doing is substituting M times 60 in for T hours, and then I have it. That's it. That's it. That's it expressed algebraically. You guys have been getting really good at that. All right. Example 2. Jack lives in New York and will be attending college in Atlanta, Georgia. The driving distance between the two cities is 883 miles. Jack knows that the speed limit varies on roads that he will travel from 50 to 65 miles per hour. He figures that he will average about 60 miles per hour on his trips. That's his average estimated speed that he thinks he's going to travel. At this average rate, how long will he be driving? Express your answer round to the nearest tenth of an hour and to the nearest minute. Now, I think you guys can do this up until the rounding to the nearest minute. That might be a little bit of a thought puzzle to puzzle out. Well, here's how to solve this. We use the same formula as before. D equals R times T. They like to do this. That's fine. This is fine. I probably don't do it this way. I probably just substitute my numbers in there and then I do the algebra. But they do the algebra right in the beginning. They say start with dividing by R on both sides of the equation, because if I'm taking R times T here and I divide by R, this R cancels that R, right? Which leaves me with just T on one side. But then if I divide by R on this side of the equation, I got to do it on this side. Therefore, I know that D divided by R equals T, and then they stick their numbers in. That's fine. It's fine if you like it that way. Great, go for it. I usually stick my numbers in to the formula, and then I do the algebra. It's whatever you feel comfortable with. Either way works. So they knew that the distance here, the distance is 883 miles. That's the distance traveled. What's the estimated rate, the R? That's about 60 miles per hour. So 883 divided by 60 miles per hour gives us the hours. Okay, so we know it'll be 14.716 hours. So it'll be 14 hours and some change. It's basically what this is saying here. It's going to take 14 hours and some change to drive 883 miles going at 60 miles an hour. The problem is we need to convert this change into amount of minutes. And here's how you do that. First, you subtract the amount of hours you've got. So I have to subtract the whole number. So I got 14 and some change. I'm going to subtract 14 right now because I'm just concerned with the change. I want to turn the change here into minutes. How do I do that? Well, this is a fraction of an hour, and there are 60 minutes in an hour. So if I take this number, and if I multiply it by 60, I'll get how many minutes are in that fraction of an hour. And I can see here, oh, 43 minutes. There'll be 43 minutes in 0.71666 repeating hours. So I know that the travel time for this particular trip is going to be 14 hours and 43 minutes, right? 14 hours and 43 minutes. That'll be how long it takes from Jack to drive 883 miles going at about 60 miles an hour. I think that was 60 miles an hour. Yes. Whew. Okay. Similar situation. Jameer lives in Rochester and he attends college at SUNY Buffalo. This little image here is the picture of the SUNY Buffalo campus. Looks pretty cool. The driving distance is 68.3 miles. Jameer knows that the speed limit varies on the roads he takes. He'll travel from between 45 miles an hour and 65 miles an hour. Jameer estimates that he'll have an average speed of about 52 miles an hour on this trip. 52 miles an hour average speed. At this rate, how long will he be driving? State your answer in number of hours and number of minutes. Round to the nearest minute. Bonus point for rounding the nearest second. Yes, you can calculate to the nearest second on these. Let me give you some think time on this. All right, hopefully you've been started already. I would say start with your formula. All right, distance equals rate times time. You know the distance is going to be, that's 68.3. You know the rate is estimated to be, it's 52. What is time in this instance? I do encourage you to try to do these on your own. When I give you that think time, don't just wait for me. You will learn so much more by, even if you get the wrong answer, you'll learn a lot more than if you just wait for me. All right, so I've got 52 times a number I don't know equals 68.3. Well, if I was to divide both sides of this equation by 52, I'd get rid of the 52 on this side, right? Dividing by 52 will cancel multiplying by 52. But if I do it on this side, I also got to do it on this side. So 68.3 divided by 52, divided by 52 on both sides of my equation, gives me t. So it's going to be 1.31 and some change. 1.31 hours. I need to convert that into minutes. How do I do that? Converting 1.31 hours into hours and minutes. Again, look at the last example that we just did to kind of look for clues on how to do these. Well, I know it'll take 1 hour at least, so I'm going to subtract 1 just to get the change, right? This is 1 hour and some change. I need to figure out how many minutes is in the change. How many minutes is in 0.313415385 hours? Well, I need to think, how many minutes are there in an hour? How many minutes are there in an hour? There's 60. So if I take this number, this is a fraction of an hour. If I was to multiply it by 60, I should get how many minutes are there. I might say I could round this up to the nearest minute, and it'd be 1 hour and 19 minutes. 1 hour and 19 minutes if I was going for the regular calculation. That's about how long it would take. However, if you wanted to, you could probably find out what this was to the nearest second if you wanted to. That's for the bonus point. All right, I won't go over that. You can try to figure that out, how to get rid of that 18 and then convert the change into how many seconds there'll be. All right, next one. Kentonio drove from Atlanta, Georgia to Denver, Colorado, which is a distance of 1,401 miles. If Kentonio averaged 58 miles per hour, how long is his driving time to the nearest minute? Start with D equals R times T. Start with that. Put your numbers in. Give it a shot. For those of you having trouble getting started, right? The distance is 1,401. 1,401, that's the distance. The rate is 58 miles per hour. So I can stick a 58 in there. Again, I'm solving for T again. If you got it, give me your hand up or give me an indication of participants, so I know you've got it already. If you don't know how to do it, then give me a no in participants. Say, I don't know how to do it. That's fine. All right, that's cool. I got somebody saying that they're struggling a little bit with this. Okay. 2 people. All right. Okay. Wow. I'm glad you're telling me. All right. So I want to find out what the time is to the nearest minute. So how do I undo multiply by 58? Right. I'm multiplying by 58 times time. I want to undo that to get time by itself. Well, I'm going to divide by 58. Right. Dividing by 58 will undo the being multiplied by 58. So, but if I do it over here, I got to do it over on the other side too. So I got to divide by 58 over here to find out what t is. So 1,401 divided by 58 gives me, wow, 24.1 and some change, 24 hours and some change. So he's going to be driving for 24 hours and some change. Well, all I got to do now is convert the change into minutes. That's not too bad. I'm going to subtract 24 to get rid of all those hours I don't want to have to deal with. Subtract 24. Now I got the change. Just going to deal with the change now. I'm going to multiply this by 60, right? This is a fraction of an hour, or a decimal of an hour. If there are 60 minutes in an hour, multiplying by 60 gives me the minutes. So it'll be 9 minutes. 0.155 hours is equal to about 9 minutes. So 24 hours and 9 minutes. All right. Now that we've done these, let's go back and practice with those. I'm gonna go back up at the very top and practice those warm-up questions. I think we can do better with them now. So let me go back up to those warm-up questions we skipped. First one, you're traveling on a highway at an average speed of 62 miles an hour, and you drive for an hour and 15 minutes. How far will you have traveled? All right, D equals R times T. It's asking me how far will I have traveled, which means I'm going to solve for D. I'm going to solve for whatever D is. I know the rate. The rate is 62 miles an hour, so I can put that in there. 62 miles an hour. I know the time. Problem is, they gave me an hour and 15 minutes. An hour and 15 minutes. What is that as like a decimal number? Well, it's going to be 1 and some change, as we've just learned, right? 15 minutes, divided by 60. There are 60 minutes an hour. Take the 15 minutes. Remember when we had the decimal? If we have 0.25, like the decimal, and if we wanted to figure out how many minutes is that, we would multiply by 60, right? To find out, oh, it's 15 minutes, which means to find out what 15 minutes is as a decimal of an hour, we'll need to divide by 60. We'll need to divide by 60 this time to get 0.25. So what we're really doing here is 62 miles an hour times 1.25. 62 times 1.25 is the same thing as 77.5. The distance traveled would be 77.5 miles. That's all it is there. That's all it is. Nothing to be scared of. Next one. If you're traveling on the highway at an average speed of 62 miles per hour and your destination is 217 miles away, how long will it take you to reach your destination? All right, well, D equals the R times the T. Oh, William, you got the answer for this one already? Woo. Well, maybe that was the last one with the driving from Georgia to Colorado, I think. All right, I got an average speed of 62 miles an hour. That's the rate. 62. This time I have the distance, 217. 217. I got to solve for T like we were doing before. Well, I'm going to have to undo multiplying by 62, which means I'm going to divide by 62 on both sides. If I divide by 62 here, yep, there we go. If I divide by 62 here, I got to divide by 62 there. So dividing by 62 over here gets rid of it over there. 217 divided by 62 gives me 3.5 hours, right? T is 3.5, 3.5 hours. I feel like you guys are getting it now. All right, another one. Your destination is 322 miles away, and it takes you 5 hours and 45 minutes to reach your destination. What was your average rate of speed? This time we're solving for the rate. If your destination is 322 miles away, and it takes you 5 hours and 45 minutes to reach your destination, what was the average rate of speed? Well, the distance was 322. The time was 5 hours and 45 minutes. Uh-oh. So it's 5 plus something. It's 5 and some change. Well, let me figure out. 45 minutes. What is 45 minutes in terms of an hour? Well, if I divide by 60, I could find out, couldn't I? 45 divided by 60 is 0.75. Right? So 5.75 is my number that goes in here. It's 5 hours and 45 minutes. It's equal to 5.75. I divide by, yeah, there we go. Divide by each side by 5.75 will give me R, right? So if I go ahead and if I divide by 5.75 over here and divide by 5.75 over here, 75, this will just turn into 1. 5.75 divided by 5.75 just turns into 1, which means all I need to do now is 322 divided by 5.75. 56, R is 56, so 56, either if you can do 56 MI over HR, or you can do like 56 MPH, right? Miles per hour. When you hear the word per in math, you should, or in life in general, you should think about division, right? Miles per hour is miles divided by hours. That's a rate of speed. That is how to attack this one. And these next two are conversion kind of math. This is conversion type of problems. We'll get more into these, I think, in example 3. But let me see. Do I have time for this? Yeah, I got time for this. 1 mile. If 1 mile is the same as 1.6 kilometers, then how many kilometers are there in 237 miles? Right? If 1 mile is 1.6 kilometers, how many kilometers are there in 237 miles? Well, this is pretty easy to think about. If 1 mile equals that many kilometers, then I know that 237 miles will be 237 times more miles over here, which means I need to multiply it by 237 more somethings over here. So 237 times 1.60934 will give me the kilometers. All I'm doing is I'm multiplying the miles by 237, which means I need to multiply the other side of this equation to be 237, which means I got about 381.4 round to the nearest hundred, 41 kilometers, km, or kilometers. Woof. One more of these. Same idea, same conversion, but now how many miles are there in 500 kilometers? This one takes a little more thought, because now I have 500 kilometers. I would like to turn that into miles using this conversion factor. Well, let me think about this previous question I just had. 381 kilometers. If I was to divide this by if I was to take this kilometers, if I was to divide it by 1.60934, it would then give me my miles, right? There's my 237 miles from the previous question, which means I can take this conversion factor and divide it by kilometers and get the miles, right? I can take 500 kilometers, divide it by the conversion factor. Last time I multiplied it to get there, but because I'm starting with kilometers, I divide it by the conversion factor, and I get, let's see, 310 point, doesn't say what, around to the nearest, maybe around to the nearest mile, 311 miles. 311 miles. Woo! Right? Once you get the hang of it, you'll be doing a lot of these actually as estimates in your head, and we'll kind of show you how to do a little bit of that. Okay, we've done the warm-ups. I'm going to go to example 3, and I think after example 3, we'll do the two questions and stop. So we're almost done. 10 minutes. Kate left Albany, New York, and she traveled to Montreal, Quebec. The distance from Albany to the Canadian border is approximately 176 miles. The distance, though, between the Canadian border and Montreal, Quebec is approximately 65 kilometers. If the entire trip took her about 3 3/4 hours, what was her average speed for the trip? All right, woof, that's going to be complex. We'll see. We'll be doing conversions and do the distance formula and all sorts of different things here. Kate's average speed can be reported in miles per hour or kilometers per hour. I'm going to deal with just miles per hour right now. To report her speed in miles per hour, convert the entire distance to miles. Change 65 kilometers first to miles, multiply by the conversion factor. So the issue here is that we need a total distance. We need a total distance. And the problem is we can't get a total distance from the beginning because we got this 176 distance in miles plus 65 distance in kilometers. So we need to convert the 65 kilometers into miles before we get started. So to do that, we're going to multiply it by a conversion factor. They're using this conversion factor right here. It's the same one that I gave you over here, right? I told you that 1 kilometer is equal to that many miles, and then 1 mile is equal to that many kilometers. So in order to make it easier for you both ways. So they took 65. They multiplied it by the conversion factor, and they got 40.389115 miles. All right, this is all about conversions, yeah. That means that tells us the distance from the Canadian border to Montreal, Canada is approximately 40 say round to the nearest tenth, 40.4 miles. We take that 40.4, we add it to the 176 from Albany to the border. We get a total distance for the trip of 216.4 miles. Woo. Now we're going to use the distance formula. D equals the rate times the time. We're going to stick 216.4 in for the distance. Then they're going to stick 3.75 in for t. Why'd they get 3.75? Well, 3 3 plus 3/4 is going to be 3.75. 3 divided by 4, right? And why is that? That's because 3 divided by 4 is 0.75. Okay, so that's how they stuck the 3.75 in there. All right, so then we find out that 216.4 divided by 3.75 will give us 57.7. That is an approximation of 57.7 miles per hour, or 58 miles per hour if we round to the nearest mph. Whew. Right, so that's kind of the idea there of how to find out her approximate rate. We can also convert this to kilometers per hour, but I'm going to skip that for now. I'm going to ask you, in example 3 above, could Kate's kilometers per hour have been calculated by multiplying her miles per hour by the conversion factor? Explain why. So take a think on this. Oh my gosh, what do I have going on out there? Sorry about that. Think about how, if this miles per hour could be converted to kilometers per hour just by using the conversion factor. Let me go turn that down. I don't know if it's the mailman or what, making this thing crazy. There's probably a squirrel out there annoying my motion detector. So if I know that she's going approximately 58 miles per hour, right? Could I use the conversion factor to change this to kilometers per hour? And I could, couldn't I? I could, right? If I know what 58 miles was in kilometers, then that number of kilometers would be how the speed traveled per hour. So for instance, if I knew that 1 mile, was equal to, say 1.6 kilometers, I could then run the conversion. What's 58 times 1.6? 58 times 1.6 gives me 92.8. That's means it's about 58 miles per hour is about the same thing as 92 kilometers per hour. So yeah, we can use the conversion. Yes, we could use the conversion to change miles per hour into kilometers per hour. All right, 5 minutes left. We have 2 more problems. All right, the situation here is we have a student that lives in Rochester, New York, that is going to travel to Toronto, Canada. So to get to Toronto, Canada, they're going to drive from Rochester all the way. They're going to get on the thruway. They're going to travel over to Buffalo, Niagara Falls, and then they're going to cross into Canadian territory there and drive from the border over to Toronto, Canada. Janessa left Rochester, New York, and traveled to Toronto, Canada. The distance from Rochester to Canada is 91 miles. So 91 miles from Rochester to the Canadian border. And the distance from the Canadian border to Toronto is 127.5 kilometers. So 127.5 kilometers. If the entire trip took her 2 hours and 55 minutes, what was her average speed for the trip round the nearest tenth of a mile per hour? All right. Should I give you, I'll give you a minute. I'll give you a minute. And then I think, yes. So just this last problem. So there's not a second one. I have time to give you a minute, and then I will demonstrate this. Your first step is to get all your distances in miles. Step 1, get all your distances in miles. To get my distances in miles, I need to take this 127.5 kilometers, and I need to convert that into miles. Which means I'll need to use a conversion factor. Mr. Cranbuell has conveniently put some of those conversion factors in the chat. I love having both conversion factors because it just makes life easier. You don't have to think about it quite so much. If I want to convert 127.5 kilometers into miles, I want to use the conversion factor that starts with 1 kilometer, right? Because if I know what 1 kilometer is, and I have something that's 127.5 times bigger than that, I know all I got to do is take 127.5 and multiply it by what 1 kilometer would equal in miles. So 127.5 times the conversion factor of 0.621371. Now these are some very exact conversions we're doing here. Usually wouldn't take out this many places, but okay, we'll say about 79 miles. We could estimate that to be 79 miles, or if you wanted to be even more precise, you could do something like 79.2 miles. Okay. Now that I have this, I need a total trip distance. This here was 91 miles, right, between Rochester and the border. And there's another 79 miles from the border to Toronto. So 91 plus 79.2. All right, 91 plus 79.2. Total trip distance of 170.2 miles. 170.2 miles. Total trip distance. And now it's about distance equals rate times time. That's that formula we keep using over and over again. The distance is 170.2. Let's see. We know the time. We want to find the rate. We know the time is 2 hours and 55 minutes. Oh gosh. I need to convert 2 hours and 55 minutes into, it's gonna be 2 point some change, right? 2 point something. Well, 55 minutes converted to an hour. There's 60 minutes in an hour. 55 divided by 60 is 0.9166 hours. So, all the way to the back. There we go. 9166. All right, there we go. That's all we need. How do I get rid of this? I'm going to divide by that number on both sides of the equation. 170.2 divided by what was it? 2 and that, yeah, divided by 2.9166 gives me an average speed of 58 miles per hour. 58 miles per hour is her rate of speed traveling from Rochester to Toronto. We are at time currently. Go to the bottom and click submit. Don't forget to click submit on these. Go to the very bottom. Oh,
Good job,
Submit,
Keyshawn,
save your work.
Will, Anaya, Shayna. Good job. We're
I'm
sticking with
stopping sharing right there.